Flip it to the back where it says relating type 1 and type 2 errors. If we want to reduce the probability of one of the errors, so I get to pick alpha, which means there is, at least to an extent, something that I am 100% controlling. Do you think I could say, well, I don't want to make either error, so let's just not make either error? That would be nice, but that doesn't happen that way. So in order to reduce the likelihood of one of the errors, what do you think we would have to give up? It would increase the other. So to increase alpha, we would what? Decrease beta. Well, usually we're not going to look for a high alpha. But to decrease alpha, we increase beta. So I could give you a scenario to where you have to go through and think about type 1 and type 2 errors and which one's which. And in the context of the scenario, a type 1 error might be terrible. And I would say, no, let's say a type 2 error is terrible. And I might ask you something like, what kind of alpha would you want, a high or a low? You would want a high. And you would have to go through to understand what type 1, type 2 errors are and the consequences, and then understand this relationship connecting it. I would never ask you which is a good alpha level to pick, which is a good beta level to pick. You would just have to understand what the errors are, what they are in context of consequences, and to make one bigger, the other one goes lower. So we've got two things here, right, that we haven't talked about. Both of these are we did it right. If I take someone to court, why am I taking them to court? I believe they've done something wrong. So would I take somebody to court that I already think is going to be innocent? No. So I'm taking them to court because I think they're wrong. If the court does what I want them to or does the right thing, then they would what? This is not a statistics term. This will not be in any textbooks. But I kind of call that the ideal scenario. If we're going to take the time to run a test, we're probably going to do it because we want to see if there's evidence that we can overturn it. That's the ideal scenario. It actually was wrong and I could overturn it. That's the whole point. The probability of this is actually called power. And power connecting with the ideal scenario should kind of make sense. At least the word choice they use for it. So power is what we want. The correct scenario. Alright, so beta, probability of type 2 error. What is my, I could write that as a conditional. I don't need to. You don't need to write this, but you can. What is the given part with the type 2 error? And then what's this part? We do what? We fail to reject. So this basically meant on that tree diagram, I already knew I was on the right side. So if I already know that I'm here, if I make this arrow go up, what's going to happen to going this way? Down. So if I'm more likely to go this way, I'm less likely to go that way. So how are power and beta going to be related? Inversely. So power in type 2. Yeah. Both are under the same condition, which is that I went to the right. So as one increases, the other decreases. So to increase power, we what? Decrease beta. Sorry, I know y'all writing. And then to decrease power, we increase beta. Power is a very, very specific term that didn't used to show up on the AP exam that much. A couple years ago, it was one question that I think actually ended up making the difference between whether some people passed or didn't. And it literally just explained like, if they found that it's like Sarah example, if they found that her levels actually were lowering, but they ended up finding later that the medicine really wasn't working, what is this talking about? And the literal answer to that entire question was the word power. And you either put it there or you didn't. And it drove some of my students that you're crazy. But so it's getting more important to the AP exam committee, whatever. So definitely something worth noting. So what are two of the things we just went over that are inversely related? Power and what else is inversely related? So, because the probability of them, alpha and beta. We just talked about it in two different scenarios. If one arrow goes up, the other one goes down. We also separately talked about power and beta are on the same limb. So as one goes up, the other one goes down. So because of that, what is my relationship between power and alpha? So this type of thing you could definitely be expected to be asked about, but it's never going to be like, find a number for this. It's going to be literally like these, knowing which one goes up and which one goes down when. So I've got everything covered on the front and everything on the back through Sarah, correct?